Everyone, welcome to the study of OD. We are going to solve this OD, which is second order and non-homogeneous. So it has two parts. We start with the complementary part whereby we are going to have y double prime plus 3y prime plus 2y is equal to 0. Now to solve this, we are going to let our y to be equal to exponential mx, so that our y prime is equal to m exponential mx. Our y prime is differentiating y double prime is equal to m squared exponential mx. So we substitute our y double prime here, which is m squared plus 3m plus 2, and we factor outside exponential mx, which is equal to 0. And we note that exponential mx cannot be equal to 0, which tells you that m squared plus 3m plus 2 is the one which is equal to 0. And this is a quadratic equation whereby it can be factorized as m squared plus m plus 2m plus 2 is equal to 0. Here you can factor m plus 1, plus the last two you can factor 2 to be left with your m plus 1, which is equal to 0. Which implies that now m plus 2 into m plus 1 is equal to 0, meaning that our m1 is equal to -1 and our m2 is equal to -2. From those two roots which are distinct, we write our y complementary as yc is equal to c1 exponential of -x plus c2 exponential of -2x, where c1 and the c2 are what is known as essential arbitrary constant. Now, to solve the particular part, yp, by the method of inverse d operator, we write it in the simple form as d squared plus 3d plus 2, and we factor y outside, which is equal to 15 cos of x. Then from there now, applying the inverse d operator, we are going to have yp as equal to 15 cos of x divided by d squared plus 3d plus 2. Then, where you have d squared, you substitute there with 1 here. The constant there is 1. So we will have 15 cos of x all over 1 minus 1 squared plus 3d plus 2, which is equal to 15 cos of x divided by 3d plus 1, because this is -1 plus 2, which will give you plus 1. The next thing, we obtain 3d minus 1, 15 cos of x divided by 3d plus 1, 3d minus 1. I have multiplied by 3d minus 1 and divided by it, which is the same thing, which is equal to, in then we can need this 15 times, or we just even leave it that way. Here we are going to have 15 times 3, that one will give you 45 d cos of x. Then you have minus 15 cos of x divided by, when you multiply this, you are going to get 9 d squared minus 1. The denominator, that is what you obtain. Now this part here, it means we differentiate. So cos differentiated will give you, it is going to give you a negative. So you will have -45 sine of x minus 15 cos of x divided by, here you have 9 into bracket minus 1 squared minus 1 squared minus 1. So which is equal to, here you have 9, -9 minus 1, which will give you -10. So you have 45 sine of x, 45 sine of x minus 15 cos of x divided by negative 10. So that is what we have. You can simplify it to obtain the following. Here there is a negative here. So our YP is equal to, by 5, 45 divided by 5, it will give you, it is going to give you 9. You shall have 9 over 2 sine of x minus, it is plus now, plus 3 cos of x. So that is what we obtain after dividing there over 2 there. When you divide here, for negative 45 divided by 10, it will give you 9 over 2. 9 over 2 sine of x. Then you have negative 15 divided by 10, it will give you 3 over 2 cos of 2. So then now our solution, I'm given OD, our OD was y double prime plus 3y prime plus 2y is equal to 15 cos of x. Y will be given by y complementary plus y particular. So we substitute, which is equal to C1 exponential negative x plus C2 exponential negative 2x plus 9 over 2 sine of x plus 3 over 2 cos of x. So that is our solution of our given ODE and BAF by method whereby we have obtained this particular part by method of inverse D operator. Thanks so much for taking your time to study with me. For more such learning, kindly tune on to my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation as we keep on learning.